Hello, Mr. Luan, alright?
Yeah.
Okay, so look at this. Okay, look at this. Imagine we are having a infinite space, and at the beginning there's only one cell, one human cell. Okay, let's say it's human cell, or aliens. At the first minute, okay, so this is initially at the beginning. After each minute, the border of the cell will spawns another new one. So there are four, right? Because look, there are four sides, and then there are four cells. And the next minute, these are the boundary, right? Boundary. So these edges, then we spawn another cells. So the question is that we want to find out the number of total cells after n minutes. To simplify, this is n equals 1. This is n equals 2. N equals 3.
Okay.
When n equals 4, how many?
20.
How is it?
25.
25?
I think, yeah, 25.
Okay. So here, here, right? This is the new cells in the next minute.
Yeah.
Yes? Am I missing anything?
No.
Okay, so let's count. How many more? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So F3 plus 12, right? F3 equals what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so 13 plus 12 is 25.
Yeah.
Okay, how about n equals 5? So let's put the values, yeah? Put the values, F values.
41.
F1 equals 1.
41.
F2 equals
41.
41. Oh, you're quick. 1, 2, 3, 4, 5. F3 equals 13, right? F4 equals 25. And then you're saying F5 equals 41?
Yeah, I think so.
Okay, so do you notice any patterns here?
Plus 4.
Here is 4. Here is 8.
12.
Here's 12. And here
16.
16, yeah? So 41 seems correct, okay?
Yeah.
Yeah, but how do we prove? I mean, we look at these. These are patterns, but how do we prove it's correct? Fn equal, we are guessing, right? We are guessing what? Fn equals Fn minus 1, obviously, right? It's based on the previous one. Plus these new cells. What are these new cells? How many are these new cells? Okay, so let's look at these. Let's look at these, alright? We can divide it into 4, right? Into 4. Here, right? This is F3, yeah? The green thing is F4. So F4 equals F3 plus, look, 4 minus 2 is 2, right? Here, 2, right? Am I right? You see? This green cells here. This green cell. These are the n minus 2. N minus 2, right? Because look, now we are working on F4. 4, n is 4, right? N is 4. So now these two are 2 cells. Times 4. Am I right? Times 4. Because there are 4 sides. But we have to add what's missing here. Here. How many are those?
4.
Just 4 plus 4. Okay? So what do we get here? Fn minus 1 plus n minus 1 times 4. Right? Can we verify here? F5 equals F4 plus 5 minus 1 times 3. Yeah, 12, yeah? Am I right? So F4 equals F3 plus 4 minus 1 times 3. Times 4, sorry, times 4. Here. This is 16, okay? 16, so times 4 is 12. So it seems correct, right? So that's how we interpret this 1612A4. Because is Fn equals Fn minus 1, the previous one, plus n minus 2 times 4 is n minus 2 is these cells on the shoulder, right? And then plus 4 is the top, bottom, left, and right. There are 4 cells. Okay? So we call this a recursion equation, right? We call this recursion equation, and we can solve this using top down, bottom up. Do you notice anything?
1, 2, 3.
What's the pattern here? If you look at this, what's the pattern?
1, 3, 5, 3, 1.
Okay, yeah, that's very good. Okay, so look, we look here, right? Here, it's actually two arithmetic sequence, right? What's arithmetic sequence? 1, 3, 5, 7, 9, right? And here is 1, 3, 5, 7. The middle is 9, for example. Alright? Yes? Look at the distance between two neighbors are always 2. So we know how to compute the sum of these arithmetic sequence, right? Am I spelling wrong?
Arithmetic.
Yeah. How do you spell it? How do you pronounce it?
Arithmetic.
Arithmetic sequence, okay.
It's not arithmetic.
Okay, can you pronounce it?
Arithmetic.
Arithmetic, okay. Arithmetic.
Arithmetic.
Okay, so look, it's actually the sum of two arithmetic equations. Right? And one,
Arithmetic.
okay,
Not arithmetic.
okay. One is just be careful. The middle one is only appears once, and we can sum two. We can sum these times 2 and minus the middle part, right? And then we can get the equation for this fn. Okay. So should we do that? Let's try. Okay, let's try. So n equals 1 is this one. N equals 2. This is this. Okay. So n equals 3. Okay. When n equals 1, the sequence is 1, right? The n equals 2 is actually 1 plus 3 times 2 minus 3, right? Middle part. The third one is 1 plus 3 plus 5 times 2 minus 5, right? Yeah? Do you understand this part? What's minus? Why do you need to minus?
Well, the minus implies the middle part because it only has ones.
Yes.
Times 2 is because it's symmetrical and it's on both sides.
Well done. Yeah, excellent. That's a quick quiz just to make sure you're listening. Oh, very well done. Okay. Yeah. Okay, so the sum 1 plus 3 plus 5 plus 7 plus 9 plus n. What's the sum of these?
Is this a coincidence or like is it the amount of numbers that are squared?
The
Is that
numbers.
the sum? For example, if they're 4, 1, 3, 5, 7.
Very well done. Yes, it's a square number, right? Look, it's 4. It's 1, 4, 9, 16. Yeah, it's a square number. Very well done. Yes, but okay. So how do we do this? Look here. Here, for example, like this is 2 times n, right? 2 times n plus 1. Okay. Look for n equal 2 times n minus 1, right? For example, like 4 items. Then when n equals 4, there are 4 numbers, right? So the last item is this one. So the equation is the first item plus the last item times how many of them divided by 2. Okay, so what's this? Look, cancel out. So it's n squared. Remember the 1 plus 2 plus 3 plus here 100. How many? What's the sum? How do we get it? The first the first item plus the last item. How many items of them? How many items?
Half of 100.
Yeah, there are 100 numbers, right?
Yes, so you times it by half.
Divided by 2. Yeah, exactly. This is the same. So if we get on these, if we use these to, I lost the track. So this is when n equals 2. Is 1 plus the last item. The last item
Is
is.
it plus 6, not minus 6?
Okay, let's try. Look, 1 plus the last item is 2 times n minus 1, right? Divided by how many items of n times n? Divided by 2 and minus 2 times n minus 1. The first item plus the last item times how many items of n divided by 2? But we need to times 2 here. Here, times 2. Okay, so 2n squared minus 2n plus 1. When n equals 3, 2 times 3 squared 9 minus 2 times 3 plus 1, which is 18 minus 6
That's 12.
plus 1. 12 plus 1, 13.
It is 13. Because 18 minus 6 is 12 and plus 1 is 13. If n is 3 is 13.
So this is correct. Look, f1 equals 1, right? f2 equals 5, right? f3 equals 18 minus 6, 12 plus 1, 13. Okay, F4 equals 2 times 16 minus 8 plus 1, which is
25. Yeah. Yes, 25.
yes, 25. So this is correct, right? Yeah?
Yeah.
Okay, so this is the equation, and obviously we can solve this using math or one constant. We can solve this using recursion, right? We can solve this using recursion, which is define fn. If n equal 1, return 1. Otherwise, return f n minus 1 plus n minus 1 times 4. This is equation, right? And put in the cache. Or we can do this for I in range. If answer equal at the beginning equals 1, range n. So answer plus equals I. Answer plus equal 4, right? And return answer. Actually, this is n minus 1. Okay? This is the quadratic function, yeah? You know that equation, right? Like that, right? Equation. So, again, we have this recursion formula. Last time we talked about plugging the 3 points, right? We plug in the 3 points and then we can solve this equation like that, right? Okay? Any questions today? What have you learned today?
About cells.
Like, working out in my head. Like, well, I know, like, I just, well,
Count.
yeah.
You count. You might notice
Yeah,
the pattern.
Like,
Like
so
1,
if you
5,
tell me to
13.
solve like F4
Yeah.
and I get the answer, and if you ask me to work out F5, I can like.
So these are the first few values.
It'll be like more easier.
So look, you notice there 4, 8, 12, 16, 20. So the next one is 61, right? So Fn equals Fn minus 1 plus n minus 1 times 4. To sum up, we can look at the numbers and observe the pattern, right? But this is a good way to cheat, right? Because we are not proving, we're just guessing. We are guessing it's the pattern like that. But how do we visualize? How do we prove? How do we interpret these are the numbers that increasing by 4? As I said, right? Every time there are two numbers, there are n minus 2 numbers on the shooter. You need to times 4, right? And then you need to add the top, bottom, left, and right, which is plus 4. So you can get Fn equals Fn minus 1 plus n minus 1 times 4. Okay, this is the recursion formula. And with the recursion formula, we can plug in the points here together. Remember this equation, ax squared plus bx plus c equals fx, right? So we can plug in 3 points to solve the unknowns a, b, c. So we get the equation here. But today we are getting this equation not by these methods. How do we get the equation of this? We look at these.
Arithmetic.
Arithmetic, okay.
Arithmetic.
Arithmetic, okay. Am I
Not
getting that?
math. It's not matic. Metic. Arithmetic.
Arithmetic. Okay, so look, today we're solving this problem by summing up the 2 arithmetic equations and by subtracting the middle one, right? And then we can calculate these equations like that, right? So which is the first number plus the last number times how many of them divided by 2. That's it for today. Bye bye. Bye bye. Okay, get ready. We go take a walk.